Welcome to Maths in Minutes at Lotus Coaching Academy. So today's lesson is going to be for grade 10s that are doing mathematics under the CAP syllabus. Okay, so first we're going to start off with week 1, which covers number systems. So firstly, we've got to understand the nature of numbers and the different types of numbers that we get. If we look at the number system, right? So we start off with, let's call it the number system. Now in this number system, it's broken up into two parts. So it's complex numbers, numbers. Then it's on the other side, it's undefined numbers. So this is something where if we have a fraction, let's call it a, and if it's divided by 0, it's undefined. Okay, now under complex numbers, we have two parts to it. Okay, it's the, let's sort of bring it over here and here. It's the real part and the imaginary part. Okay, and most of the time for grade 10, we're going to be dealing in the real part of number systems. Okay, so under the imaginary, or another way to call it is non-real, an example of that would be anything. So let's say the square root of a negative number would be imaginary or non-real. So under the real aspect, we have two parts to it, which is now, let's break it down even further this way and this way. It's rational and irrational, right? So even numbers can be irrational at times. Okay, so under the irrational aspect, there's two parts to it. Let's say surds and non-terminating, so let's call it non-terminating decimals. Okay. Okay, and an example of this would be something like 2,351 ... So it doesn't end. Too many dots there. Okay, and under surds, so this would be something like square root of 5, anything with a surd. So this shape here is a surd. Okay. Now let's go back to rational. The rational side has two aspects to it, which is either integers, right? Integers, and fractions. You've seen fractions, right? Fractions. Okay. And then lastly, under integers, you'll have either whole numbers or natural numbers. So hopefully this fits in. Let's see. Sure. Okay. So we'll have whole numbers and natural numbers. Okay, so let's see. Whole numbers would be anything from 0, 1, 2, 3 going on, and natural numbers would be from 1 going up. So now we're going to do an example of recurring decimals and write them as fractions. Okay, so let's take the example of 0.7 recurring. Okay, so how do we represent this in a fraction? So let's make x, let's call this x. X is equal to 0,777, and it'll be recurring, right? So what we do here is we first multiply the left and the right by 10, so we get 1, or the first significant number. So what we do to the left, we must do to the right. So 10x is equal to 7.7 recurring. Okay, so how we get it into a fraction is you basically go one less, or if we need to trunk out the recurring. So if 7.777 isn't an actual whole number, we go one integer back. So one integer back of 10x is 9, so 9x. And we want to trunk out basically this recurring decimal, so it'll just be 7. So now we just solve for x. So we divide both sides by 9, and therefore x will equal 7 over 9. Right? Pretty simple. Okay, let's do another example. Let's say number 6. Okay, let's say we have 0.813, but the 8 and the 3 are recurring. Okay, so something similar. We'll say x is equal to 0.813. You'll say 813. Okay, because we wanted these numbers to recur every time. Even though the 1 doesn't have a recurring, it still is a placeholder between the 8 and the 3. So we need to repeat that pattern. So how many significant figures are there? It's 1, 2, 3. So we multiply by 1,000. So we multiply the left by 1,000, 1000x, and the right 813,813. Okay, so similar to this method, one number back is 999x is equal to 813. Therefore, divide both sides by 999, and you get x is equal to 813 over 999. 9 will simplify into x is equal to 271 over 333. And that's your answer. Okay, let's do one more just to make sure that we understand this concept. Okay, let's do... Okay, we have 3.523 recurring. Okay, a bit different. Now let's look, if we were to say x is equal to 3.52, but now only the 3 is recurring. Okay, because the recurring integer is at the end, we will write these two significant figures and only recur at the end, not like the last one where it was the non-recurring number was in between two recurring digits, so we had to write it in. But this is a bit different. So what do we need to multiply by to get to just before the recurring digits? It's how many decimals? 1, 2, which is 100. So we'll multiply the left by 100 and the right. So you'll get 352,333, and that's basically just recurring. Okay. Now, this looks just like, well, we can put the dot there, just like the first question. When we had the recurring after the decimal, what did we do? We just multiplied by 10. So we do the same thing. So if we multiply this by 10, the left and the right, you get 1,000x is equal to 3,523 recurring. Okay? So these ones are a bit different. So now what I'll do is I'll label it equation 1 and equation 2. And now in order to solve, I'll just go 2 minus 1, which will give me 900x, because 1,000 minus 100. And let's see, maybe employ the use of a calculator. 3523.3, or recurring, minus 352.3 will give me 3171. Because you look, the recurring decimal on equation 2 will cancel out the recurring decimals on equation 1. So I'm left with 900x is equal to 3171. Divide both sides by 900. And I should get x is equal to 3171 over 900, which is really equal to, if we simplify, 1057 over 300. Okay? So now we're going to touch on something called surds. Okay, so surds. And really a surd is that. And we can have them to many powers. So generally when it's not written like that, it implies it's to the power, or it's to the root of 2. So I'm just going to put it in here because we can have a surd to any power really. So surds. Okay, and surds. So the key to surds is to know your square roots. So initially you'll be using a lot of square roots. So let's go through the basic numbers, right? From 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want to find out what the square is. So if we square these numbers, as in the number times itself, so 1 times 1, we'll get 1. 2 times 2, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. And 100 squared, 10 squared is 100. Okay, so it's vitally important to know these, as you'll use it in maths all the time, okay? So let's see how we can use this, right? So if I look at the number, if I say square root of 5, and my question is, which two integers would the answer to this lie? So if I were to put it in the calculator, square root of 5, it comes out as a decimal, right? So as 2.236, let's call it, oops, whoop, 6, okay? All right, so if I look at this, where does it lie between? We said the answer is 2.236, so it should be between there, okay? But now if I just look at the surd without even using the calculator, it says the square root of 5. So I look here, where does 5 lie in between? It's between 4 and 9. So the integers it must lie between is 2 and 3. So that's the sort of concept we're going to use here. So let's look at another example. Let's take square root of 10. Square root of 10. So where does 10 lie in the answer here? It's between 9 and 16. And that's between the integers of 3 and 4. So the answer to this would lie between 3 and, well, let's say it's an element between 3 and 4. Okay, and if we do one more, let's say square root of 36. Let's look at where it is. Oh, look at that. It's a perfect square. So the square root of 36 is 6. That's an easy one. Okay, so that's basically how surds work. And more specifically, this is when n is equal to 2. Right? So we're looking at square roots here. Okay, so if we square root these numbers, we'll get the initial numbers, and preferably from 1 to 10. Okay, so that basically covers the first week of grade 10 mathematics under the CAP syllabus. Okay, so it's pretty easy, right? So what I'd recommend is looking at your textbook, going over some examples, and you can just watch this video over and over again. So if you enjoyed this, if you want to know more, hit the subscribe button, hit the like button, share it with people. You can write in the comments if you have some alternate method that you'd like to share with everyone. If you just want to give me feedback, it's all welcome. Remember, maths has many solutions to the same answer, and your feedback is welcome.